Hi, my name is Juliana Reynolds, and today I will be speaking about an assessment of green stormwater infrastructure research and gaps in arid climates. So today's presentation, we're going to go through a couple different topics, including arid climates, green stormwater infrastructure, a literature review, a visualization, results, and then conclusions. So a little bit of background, arid climates receive less than 250 millimeters of rainfall annually. That arid classification also comes from metrics such as temperature and vegetation, but mainly rainfall amounts. Example locations include the Southwest US, including Phoenix, Tucson, Albuquerque, New Mexico, parts of Nevada, and the internal areas of Australia and Saudi Arabia, just to name a few. So what is green stormwater infrastructure? It's an alternative to traditional stormwater captures that utilize measures like vegetation and soil to store and allow infiltration of stormwater. Traditional stormwater measures are designed to move water rapidly to prevent flooding, but can reduce the likelihood of water properly infiltrating the soil and recharging groundwater. So there are several different types of green stormwater infrastructure. There are bioretention ponds, curb cuts, rainwater harvesting systems, infiltration trenches, green roofs, permeable pavements, retention basins, rock detention structures, swales, and traffic chicanes. In climates that receive little water, it's imperative that rainwater doesn't go to waste. So all of these are designed to collect and store rainwater in some sort of way. Just a little visual for everybody. The top left is a green roof rendering for a building in Colorado. The left bottom is the diagram of a bioretention pond. As you can see, there is vegetation on top. There's that bioretention soil, a gravel bed, and then the native soil, all of which are designed to move water and slow it down so that it can infiltrate into the native soil. On the right, we have an infiltration trench. It's similar to a bioretention pond where it's supposed to slow water down and allow infiltration into the soil. So my project objectives included the review and analysis of the current literature on green stormwater infrastructure, specifically in arid climates. There's currently a ton of research with GSI in temperate locations, but there's a lack of research in arid climates. So I compiled relevant literature based on specified criteria and then created a dashboard and a visualization for the Arizona Tri-University Recharge Project. So a little bit of background on the literature review. We can go into the search. My keywords were all over the place, trying to capture as many papers as possible. I used anywhere from stormwater to urban to green stormwater to infrastructure, trying to get as many papers. And I also used the references from papers to expand that search. So I ranked every paper that I came across on a scale of 1 to 3. Relevancy was determined originally by information provided in project meetings. And over time, as I became more familiar with what I was looking for, I was able to narrow down what I wanted. So the biggest thing was, is it an arid climate? If the paper was not in an arid climate, I would still include it if they were using GSI, but that paper would score a 3 on the scale, whereas arid climates would score a 1 or a 2. What were their study goals? I was looking for content on GSI specifically, and if they were using GSI, what type were they using? Were they using green roofs? Were they using rainwater harvesting, infiltration, etc.? And what were the study results? The most important thing was quantitative metrics. I was looking for percentages, was looking for a whole bunch of like repeatable studies, and not specifically tied to GSI, but urbanization is also super important. So it wasn't an aspect that I ruled out. While it wasn't the primary focus of the project, these papers that were included for urbanization were also included in my overall search. So overall, I found 79 papers. 70 papers were read. 36 of those papers scored at least a 2, so a 1 or a 2, and there were 20 papers that scored a 1. So moving to the metrics that I used to record and keep track of these papers, the biggest thing was location. The second thing was methodology. A lot of these papers either were empirically studied or modeled. Empirical meaning an actual GSI location, like a neighborhood that installed a bunch of different GSI, like green roofs or retention ponds or something on plots of land. Excuse me. Or did they use modeling software to simulate various types of GSI with stormwater and rainfall? The GSI practice that was used was also recorded. So if they used rainwater harvesting or bioretention or retention ponds, that was recorded. And what were the results of the study? Like I said, I was looking for papers that yielded quantitative results, like green roofs that can retain 60% of rainfall. That came out of Pumo et al. 2013. The papers on the right are all of the papers that scored a 1. So if we move a little bit closer into these papers, I've grouped these papers based on their results. So we've got runoff, peak flow, water budget, and savings and capture, downstream flow, and then urbanization. These papers scored a 1, and runoff, they found results regarding runoff, specifically that GSI reduces runoff. Peak flow is similar, where GSI reduces peak flow times as they slow the water down. These are the rest of the papers that scored a 1. One of the papers, they found peak flow reduction, and they found that there was no downstream flow effects of stormwater capture upstream. The rest of the papers are GSI and water storage, savings, capture, and budget. So they found that GSI could increase those metrics. All of the urbanization papers, most of them did not have any GSI associated with them, just metrics with urbanization. So there were 2 methods of visualization, a hierarchical diagram that illustrates the relationship between papers in the big 4, meaning location, methodology, GSI type, and result. And then an experience builder, which explores those papers spatially. So I'm going to get out of here and I will show you the dashboard that I created. So here is the dashboard. We've got all of the papers plotted on the map. We can see that there are a lot of papers in the southwest of the United States, and then a couple other papers throughout the world, but heavily concentrated in the southwest. We have filters on here, so if we wanted to know what papers came out of Arizona, we can come over here and we can see them. We can also go through methodology, so we can see, okay, those papers are the papers that are modeled versus empirical. If we want to know what kind of GSI practice they use, let's say rainwater harvesting, only 1 paper used rainwater harvesting. And if we click on that one, we can see a little bit of background on this paper. So we've got the title, we have the authors of the papers, the DOI, so we can look it up later, the specific location or the state, and then a summary that I wrote with the relevant information for the paper. We've got the methodology and the GSI practice, excuse me, and the result. Some papers had multiple GSI practices and multiple results. So if I leave here, and I want to try to find paper that has multiple results, we can see that, or maybe not. Go through here. Anyway, we can see that there are papers that probably have multiple results. There are papers in here. I just don't remember which ones. And then we can come to the visualization that allows you to understand the relationships between papers and their topics or their big four categories really quickly. So we can come over here. We've got location, this is interactive location, results. We've got the methodology, the GSI type, and the paper itself. So if I wanted to know what Reed et al. Was about, I could come over here and it tells me that excuse me, 8 outgoing items. We've got a modeled paper that uses swales, permeable pavements, infiltration trenches, dry ponds, bioretention. It's out of California, and they found a reduction in peak flow. We can come down here and do the same thing for the rest of the papers. This one was an urbanization paper because it didn't use any GSI at all. And we can do the same thing on the other side. So if I wanted to know how many papers used rainwater harvesting, we can see that there were 6 papers. We can do that for the same with Arizona. Arizona is the leading, producer of research in green stormwater infrastructure in arid climates. And we can come through here and see which papers or how many papers come out of each result. So there are 5 papers that found results regarding peak flow. So I'm going to come back to my presentation. And so general paper findings, green stormwater infrastructure reduces peak flows and runoff. It increases water storage, water savings, water capture, and water budget. Downstream flows are unaffected by stormwater capture and GSI. There were 2 papers that found that. And urbanization increases runoff and stream flows. So in conclusion, GSI is a super important method of stormwater capture in arid environments, as evaporation is high with traditional stormwater storage methods. And it's important to capture every drop of water that we can. Runoff and peak flows can be reduced with the implementation of GSI, while water savings and related items can be increased. And empirical studies can be conducted, and there are a lot of them, but more need to be conducted to validate the models that are used in the papers that use models to validate and estimate that green stormwater infrastructure performance. A couple other notes. If I had had more time, I probably would have explored the results compared to GSI practice. That would have been a really cool thing to look at. And do arid results yield similar results to temperate climates? And thank you so much.